Hey everyone! Today we're going to talk about a concept in algebra that is all about working smarter, not harder. It's a super powerful shortcut for when you have to do the same multiplication over and over again. I mean, imagine you're a programmer, or really anyone, and you have to write this out maybe 100 times. That would get old fast. It's messy, it takes up a ton of space. There's got to be a better way, right? And there is. It's just 2 to the 5th power. So simple, so elegant. This is what we call exponential notation, and it is the exact shortcut we were looking for. It takes all that repetitive work and just squishes it down into 2 little numbers. But what do those numbers actually mean? All right, so let's break this down. What are we actually looking at here? This new way of writing things has 2 key parts, and once you know the lingo, you're halfway to mastering it. Okay, first up, you've got the big number on the bottom. That's called the base. You can kind of think of it as the foundation, right? It's the main number, the one that's going to be doing all the work, getting multiplied over and over again. And then there's that small number kind of floating up top. That's the exponent. Sometimes people call it the power. The exponent is basically the boss. It's the instruction manual. It tells the base exactly how many times to multiply itself. So here's a perfect example of how they team up. When you see 3 to the 4th power, your brain might want to jump to 3 times 4. But nope, that's not it. It means you take the base, which is 3, and you use it as a factor 4 times. So 3 times 3 times 3 times 3. Okay, so we know what the parts are called. But how do we go from this neat little package back to an actual number? Let's walk through how to do the math. It's actually a really simple 3-step process. First, you just expand it out. Write down the long version, 3 times 3 times 3 times 3. Then you just multiply, going from left to right. So 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. And that's it. That's our final number. The most important thing here is remembering that 3 to the 4th power is 81. Oh, and a quick side note on how you actually say these things out loud. You can always just say to the power of. That's totally fine. But, mathematicians have a couple of special nicknames for the most common ones. If the exponent is a 2, you say squared. If it's a 3, you say cubed. For anything bigger, you just go back to saying to the 5th power, to the 6th power, and so on. Easy enough. All right, now like with pretty much everything in math, there are a few little traps and special rules you gotta watch out for. Nailing these details is what really makes the difference, so let's get into it. Okay, here are 2 super important shortcuts. First, any number to the power of 1 is just itself. That makes sense, right? You're only using it as a factor 1 time. Now, the second one is a little weird, but it's huge. Any non-zero number to the power of 0 is always 1. Not 0, 1. For now, it's one of those things you kind of just have to memorize. Listen up, because this is hands down the number 1 mistake that trips people up. Your brain sees that 3 and that 4, and it just screams multiply them. It's 12. You have to fight that urge. Remember, the exponent isn't part of the multiplication. It's the instruction for the multiplication. So 3 to the 4th is 81, 100% not 12. Okay, you're going to want to pay super close attention to this one because a tiny little thing like parentheses can completely flip your answer. So look, when you see parentheses around the -3, the entire thing is the base. That means you're doing -3 times -3, which gives you a positive 9. But if there are no parentheses, that little squared exponent is only attached to the 3, not the negative sign. So you do 3 squared first, that's 9, and then you tack on the negative sign at the front. The answer, -9. See? Huge difference. Those parentheses are everything. Okay, so right about now, you might be thinking, all right, this is kind of cool, I guess, but when am I ever going to use this in real life? Well, here's the thing. You already use it. Every single day. You just might not realize it. Seriously. From how fast your computer is to how much storage you have on your phone, our entire digital world is literally built on the math of exponents. And almost all of it uses the number 2 as the base. Just take this expression right here. 2 to the 30th power. This is actually the number of bytes in 1 gigabyte of data. You see that term gigabyte everywhere, right? On your phone plan, your laptop. So what huge number is this simple little expression hiding? It's over 1 billion. No, seriously, the number 2 multiplied by itself 30 times is over 1 billion. And that right there is the magic of exponents. They give us this super clean, simple way to write down and work with these gigantic or sometimes incredibly tiny numbers. So, wow, we've covered a lot, right? We talked about the parts of a power, how to calculate them, and, why they actually matter. But I want to go back to that one weird rule for a second. We learned that any non-zero number to the power of 0 is 1. But the question I want to leave you with is why? Why does that work? What's going on with the patterns in math that makes that rule true? Something to think about.